Yes. Let me start today's lecture with this slide. The students, please, who understood everything, please bear for the sake of 2 to 3 minutes. As all of you are aware that the control system engineering is the complete problematic topic, under which I have started the first problematic topic, that is the determination of transfer function, which will conclude your unit 1, under which in the previous classes we have concluded how to find out the transfer function of electrical system. And now also in the same way, in the previous week I started what is a mechanical system and how to determine the transfer function of mechanical system. Under mechanical system, as all of you are aware, based on the motion, mechanical system is classified in 2 categories. That is mechanical translational system and another one is mechanical rotational system. In the previous class, I have concluded how to obtain the transfer function of mechanical translatory system. In this class, we are going to conclude and learn how to solve the problem related to mechanical rotational system. Simply, I can say that if you know how to obtain the transfer function of translational system, then I can say you know how to obtain the same for mechanical rotational system. Yeah, before going for problems, just I will just take a glance of this mechanical system what I started in the previous week. So what is mechanical system means? It is a motion of physical object comes under mechanical system, and based on the motion it is classified into 2 categories, that is translational and rotational. What is translational motion means? It is the motion of the physical object or body along the straight line. Horizontal motion comes under these categories. That is, the object is having the motion, the consequence will be the displacement. That is with the object with the motion, the object can have the tendency to move from one place to another place. But if you compare with your rotational system is also having a fixed motion, but the status of that particular motion will be around its only fixed axis. It means that the movement of that particular body cannot move from one place to another place. It is only around its fixed axis. Of course, both are moving, but one is at a standstill and another one is horizontal movement. Now, majorly under mechanical systems, I have already given you the clear idea that the elements under mechanical systems are M, B and K, and the explanation of this one already clearly explained in the previous class, and the variables are force and displacement X. Now, obviously, if you are applying some force on a physical object, obviously you will be getting what displacement X. Some movement వస్తుంది. మీరు ఒక వస్తువుని తీసుకొని ఒక కొంత ఫోర్స్ అప్లై చేసి దొబ్బితే అవుట్పుట్ will be the displacement. Here also the same thing what I have put in the slides. Nothing is new to all of you here. And based upon the element property, it has been classified into M, B and K. Similarly, under mechanical rotational systems also, the variables are same, that is J, B, K. Okay, but denotions only the change. For mass J and for force it is termed as torque, and for X displacement theta. And now final slide is of the introduction to previous classes is you must remember the mathematical relationships between elements and variables. Suppose for example in electrical circuit, if you are having R element, then what is the relationship between its element R with variables voltage and current? Means you can say directly from the laws V is equal to IR. In the same way, from the laws of physics, it has been already derived. Just I am using those formulas. That is F is equal to M into D square X by dt square. Is the mathematical relationship for the mass element with its variables force and displacement X. In the same way, for B it is dx by dt, and for K it is K into X. And it should be noted that for mass element there will not be any another displacement if the element if you observe these three, the other ends of these 3 elements is grounded. If suppose for example if the other end is not grounded, ఇక్కడ నుంచి ఇంకో ఫోర్స్ అప్లై చేసి దీని ద్వారా టు అండ్ ఫ్రో మూవ్మెంట్ ఉంది అంటే మాస్ ఎలిమెంట్ కి ఎట్టి పరిస్థితిలో ఉండదు, ఇది ఏదో డైరెక్షన్ లో మూవ్ అవుతుంది కాబట్టి యూ షుడ్ నాట్ కన్సిడర్ యాజ్ అ dx minus dx. But here in this case If let here x1, let at the other side instead of ground it is x2, then you need to consider b into dx1 by dt minus dx2 by dt, as what we have solved in the problems. And in the same way, for the spring element, it is k into x1 minus x2 if it is connected to another end. I think just only it should be noted. That's it. In the same way, for a mechanical rotational system, for in the place of force, force is just replaced by torque, and x is replaced by theta, and m is replaced by j. Remaining all are mathematical expressions are same. Okay. Now I have last two classes we have solved the determination of transfer function of mechanical rotational system by following this procedure. Now in this class I am having 40 minutes of time. Based upon this time factor, I am going to solve the number of problems. This is your first problem. Let me solve. As usual, then nothing is there in this particular procedure. As usual, in the previous class, you assume x as nodes. Now you need to assume theta as the nodes. And in the same way, draw the free body diagram, and then third step is writing the differential equation. Once if you got the first three steps, then remaining two steps are nothing. That is simply applying Laplace transformation and just rearranging the terms to get the ratio of what output by input. Remember, here I am considering theta of s. Theta is the output variable and torque t is the input variable. Now let me solve this problem. First problem. If you are facing any problems related to my voice or display, please feel free here. Now this is my first problem. Today's class first problem what I am going to solve here. So he is asking you to find that you need to note down in parallel with me. Find the transfer function theta of s divided by t of s is the question. Okay. Now the question here given is, I am just redrawing that diagram from the slides. He has given one spring, and now here he has given one dashpad element and one disk. It is connected to one disk, rotating disk. Okay. So this disk is having mass j, k, and frictional. Other end is connected to grounds. Let t is the applied torque. With that torque, you are getting one rotational motion which is known as theta. This is the given question. Given. Let me divide this page into two parts so that it will be very easy for me. Okay. Now I am solving, as it is a first problem. Just note it down in parallel with me. Here if you observe, here is only one element named as theta, and the variable related to theta is obviously torque, and the elements are j, b, k. The other three elements. To draw the free body diagram, just theta, just parallel ga rasayala. What is free body diagram? What you assume that particular node, our node ki connect aina elements anni parallel ga rayala. So the first element is the variable t, and the second element is j, and the third element is the damper element b, and the next element is last element is k. What he has given. This is your first step. Second step is drawing the free body diagram. Free body diagram. And next third step is you need to write the equation at each and every node. Now here only one node, hence at node theta. What is the equation? Input is torque t, just like KVL. Input is torque t, and the output will be the torque due to Jm plus the torque due to the torque due to B plus the torque due to opposing torque due to K. All of you are aware the expression when J and for T it is equal to mathematical J into d square theta by dt square plus b into d theta by dt plus k into theta. Equation 1. Now next steps are you have to apply what Laplace transformation and rearrange the terms. So fourth step is applying Laplace transformation. Then you will get T of s is equal to Laplace of d square is the same. So j into s square into theta of s plus b into s into theta of s plus k into theta of s. So what is he has asked? Transfer function ratio between output by input. So ratio between output by input అడిగినాడు కాబట్టి just I am taking the common term t of s is equal to what you will get j into s square plus bs plus k into theta of s. Or finally I can write the transfer function theta, rearranging the terms, that is theta of s. The fifth step is rearranging the terms. Theta of s by t of s is equal to 1 divided by j s square plus bs plus k is the answer. Any doubts? Unmute and talk. Otherwise, I will jump to the next problem. Here is the end of. You take the screenshot. If you are very late, you can verify it later. So overall summary of this problem solving is first extract the variables related connected to each and every node, then draw the free body diagram, and then write the equations at each and every node, and then apply Laplace for those equations, and then rearrange the terms in terms of asked variables. Don't worry, he will be asking you the transfer function relating the variables. Here is the end of my first problem. Now second problem. Today's class second problem. Find the transfer function theta 2 of s by t of s for the given mechanical rotational system. So let me draw the next question. So second problem I am just noting here. A B1 star T theta 1 theta 2, and this is the element is B2. This is the given diagram. Now if you observe as a solution, as a second problem, I am going to solve this problem. Don't worry. Any doubts, unmute. Be feel free here. Make this class as a friendly atmosphere. So solution here is to draw the free body diagram. So first you need to extract the nodes. So here there are two nodes in this problem, theta 1 and theta 2. Now if you observe here, the variables are elements connected to theta 1 are, one is J1, okay, another one is torque T as usual. So hence I am just directly writing torque T and J1 are connected to only theta 1. Now, but physically if you see, in between theta 2 and theta 1, J2, K, B1, J1, four elements are there. But నేను already చెప్పినానమ్మా మీకు, mass cannot be considered as a two displacements. To and fro movement ఉండదు mass కి. కింద పడితే ఒకే డైరెక్షన్ లో పోతుంది. బట్ స్ప్రింగ్ కి టూ డైరెక్షన్ ఉంటుంది కాబట్టి you can consider as a common element. Now coming to theta 2, the element connected theta 2 are J2, B2. There are two elements. If you observe B2 another end is connected to ground, and if you observe J2 another end is connected towards theta 1, but you can't consider the mass elements as a common element. Hence J2 అనేది కామన్ తీసుకొని ఇక్కడ, which is B2, and the common element is between theta 1 and theta 2 are, what are the common elements? K and B1. K and B1. Now drawing a free body diagram. I am just drawing a free body diagram. Let me draw. So for theta 1, as usual, for theta 1, the elements connected to theta 1 is theta 1, J1 and torque T, and the elements for connected to theta 2 are, one is J2 and the another element is B2. And the common elements here are, there are two common elements. That's why I will use parallel. And the common elements here are, one is K and another one is B1. So this is the free body diagram for the given new problem. Next problem. As I request all of you that while viewing the screen in the Google Meet, please try to make it full screen so that the visibility of the what I am writing will be very clear. If you are using laptops, please use full screen mode in the viewing mode. Now next is, you need to write the equations. So first equation will be, so at node theta 1, at node theta 1, what will be the equation? T is equal to J1 into T square theta 1 by dt square, plus there are two elements which are common, B1 into d theta 1 by, as you are writing with respect to theta 1 minus theta 2, plus K into theta 1 minus theta 2. Equation 1. And similarly at node theta 2, what will be the equation? LHS is 0 as there is no torque. Okay, LHS is 0 at node as there is no torque. What will be the equation? First equation is J2 into d square theta 2 by dt square, plus B2 into d theta 2 by dt, plus one element is there, that is B1. Now this time it is d theta 2 by dt minus d theta 1 by dt. plus k into theta 2 minus theta 1. Equation 2. Almost over. Now I am applying Laplace transformation as a fourth step. I am just removing all these things. I hope you noted the first problem. So applying Laplace transformation, then you will get equation 1 implies directly rastanama T of S is equal to, let me take some another color only for the sake of students. What I am going to work out with this one. So here applying equation, applying Laplace for equation 1, then you will get T of S will be equal to, so here J1 S square plus B1 S plus K into theta 1 of S minus B1 into theta 2 of S minus K into theta 2 of S. Equation 3. Now further equation 2 implies 0 is equal to J2 S square plus B2 S plus B1 S plus K. Common తీసేసుకున్నాను of what? Theta 2 of S minus B1 S into theta 1 of S minus K into theta 1 of S. Now here in this given question, he has asked you to find out what theta 2 by T. Now if you observe equation 1, if you observe this equation 1, T of S is equal to left hand side I am having one variable which is I needed T of S. Right hand side నాకు కావాల్సింది ఏమి theta 2 of S. Theta 2 of S variable is available here and also here. Now I don't want this variable. Star పెట్టినాను కదా, I don't want this variable. So ఈ వేరియబుల్ నాకు అవసరం లేదు కాబట్టి what I should do here is just I am sending this negative terms to the left hand side. Then you will get left hand side theta 1 of S is equal to right hand side ఏం మిగులుతుందమ్మా J2 S square plus B2 S plus B1 S plus K into theta 2 of S divided by left hand side already కొద్దిగా ఇది పంపించినాను, left hand side వెళ్తే that was become plus, so B1 S plus K. You assume this one as equation 4. Okay, now substitute this equation 4 in 3, then you will get I am just coming from space undi. So if you substitute equation 4 and in equation 3, then this equation will be only in terms of theta 1 and theta 2 of S. Sorry, theta 1 can be replaced with this particular one. Now if you observe this equation only in terms of theta 2 of S, so hence you can write the expression for what theta 2 of S by T of S. By substituting you will get then you will get what T of S is equal to J1 S square plus B1 S plus K into equation 4. ఇది fourth equation. తర్వాత మళ్ళా ప్లస్ మైనస్ B1 S minus K into theta 2 of S. Now taking here theta 2, here theta 2, you will get the final answer. As I am just erasing your question, I will write here. I'm just arranging here. As this part you can easily understand. So you will get theta 2 of s by t of s is equal to the final answer is in the numerator b1 s plus k, and in the denominator, verify later on, j2 is s j1 s square plus b1 s plus k multiplied by, as usual, ingoti emundamma, j2 s square plus b1 s plus b1 s plus b2 s plus k minus b1 s plus k is the final answer. Note down. Next, third problem. Please make a note. Meanwhile, I am going to draw the third problem. Theta L of s by theta m, sorry, Tm of s. Just variable names change. Very easy problem. Just I am drawing like this. Motor, motor connected to load, that is through shaft. మీరు మెషిన్ ల్యాబ్ లో చేసింటారు. Through some mechanical drum, motor is loaded like this. So this motor is having mass J and having friction Bm. So at the motor side, the torque is Tm and the displacement is theta m. This shaft is having some property of what? Spring property K, and at the load side, this is theta L, and this load is having mass, only mass JL, no friction, no spring. This is the question what he has given. Please try to solve the third problem. I am giving the time to the students. Please try to solve in parallel. Actually, this is s square. Okay. And remember, all of you, while solving these types of problems, so in general, because of multiplication, etc. Everybody may not get exact. Suppose if you run to multiply cheste, further simplify it maths. So I'm not doing like this. I need here whether you know how to find out theta 2 of s by t of s. So in the exam point of view, you are going to get the marks based upon the procedure how you have done. Mara further ఇవన్నీ మల్టిప్లై చేస్తే ఆన్సర్ మళ్ళీ మారిపోతుంది అట్లా. Okay. Further any doubts, you can use your unmute and talk. Now next continuation of this problem. Let me continue. So first step is you have to extract the variables which are connected. You have to extract the variables which are connected. What are the variables which are connected here to theta? How many displacements he has given? 2 displacements he has given. So here he has given 2 displacements, angular displacement. One is theta m and another one is theta l. Denotations మారిపోయింది అంతే, అంతకు మించి ఏం లేదమ్మ. What is theta m? Variables connected. చూస్తేనే చెప్పేసేయాల. This is the third problem. So one is theta m, torque available at the input side, and then another one is jm and another one is bm. And now next is for theta l, the elements are only jl, no further he has given, and further the common element between theta m and theta l is only k. Now drawing the free body diagram for this one. So next step is based upon the given data, drawing the free body diagram. So here he has given drawing the free body diagram for this one. So I can write here as one is theta m and another one is theta load. So first is torque T element, next element is jm, and next element is bm. These symbols to rastam. Remember, he has not given any symbols, only denotations ichinaru. Denotations ichina you need to consider. Ade important. Denotation ichina symbols badlu, the graphical symbol badlu normal text symbol ichinaru. Text symbol untene consider cheyala. So this is J, L, and the common element here is K. Common element is K. Okay. Now writing the equation at as usual, writing the equation at note theta m. What you will get? I am just removing these things. So at note theta m, what you will get here? Tm is equal to jm d square theta m by dt square plus bm d theta m by dt plus k into theta m minus theta l. Plus k into theta m minus theta l, common element. Now at the next node, what you are going to get here? At node, which node? Theta l. See, as there is no torque here, if you observe, at node theta l, there is no torque. Okay, if there is no torque, Then left hand side is 0 and right hand side is j l, as you are writing with respect to theta l, so d theta l by dt plus k into theta l minus theta m, equation 2. So this is 1 and this is 2. Now next is you need to apply what a Laplace transformation for those expressions. Now then rearrange the terms to get the ratio of what theta l by t of s will be the end of problem. So then equation 1 implies if you apply Laplace transformation, then Tm of s is equal to direct rasanama Jm s square plus Bm s plus k. This is theta m of s minus k into theta l of s. Equation 3. And now equation 2 implies if you apply Laplace, 0 is equal to jl s square so 0 is equal to j l s square plus k into theta l of s minus k into theta m of s. Further, now in this problem he has asked you to find out theta l by tm. Now if you observe this expression, tm undi already. Now right side if you observe, theta l is available at the negative part and theta m is the unknown variable. So this theta m can be considered as unknown variable. This theta m is considered as unknown variable. Now you need to eliminate this theta m. To eliminate this theta m, just I am sending this theta m to the left hand side. Then you will get a theta m is equal to theta m of s is equal to left hand side. If you send, then in the numerator here you will get j l s square plus k divided by k with of what theta m into theta l of s, equation 4. Now as usual, substituting equation 4 in 3. Substituting equation 4 in 3. Then you will get the final answer as theta L of S by T M of S. Verify your answer with this one. In the numerator, you will be getting what? K divided by actually it's a lengthy equation. I am writing here the answer. This is equal to J M J L S power 4 plus J L B M S square plus S power 3 S power 3 plus JLK S square plus JMK S square plus BMKS. Compare your answer with this one. Almost you will be getting the same answer. Okay. Here is the end of this problem. Here is the end of BMKS. Here is the end of this problem. Now, finally, last 5 minutes is there. Let me go ahead with this last final additional problem. If you are having doubts, any doubts, you can unmute or talk. Now here I am going with this last final problem in order to make you clear whether you have cleared or not all these concepts. So I am just taking this problem as a complementary problem. So you please try to do this problem. Just write the differential equation. That's it. Now he is not asking any transfer function. So write the differential equations. So J1, J2, J3, K1, K2, K3. Here T comma theta 1 and then B1 with ground. Here theta 2 and now here theta 3. Here B2 with ground and here B3 with ground. Now you data chustene only write the differential equation. Exam point of view almost you will be getting what only for 2 notes. Then additional time in the 5 minutes kavati I am just asking you this problem. Theta 2 and there are 3 nodes theta 3. So you can observe just there for theta 1 the elements are only torque T and then J1. Now if you consider B1, B1 can be considered as what other end is grounded kavati theta 1. Similarly for theta 2 if you observe the element is J2 and B2 and for theta 3 the elements are J3, B3 and K3 and the common elements are common element between theta 1 and theta 2 is only K1 and between theta 2 and theta 3 is K2. Now if you observe physically theta 2 ki theta 1 ki madhya how many elements are there? J1, B1 and K1, but you are considering only K1 as a common element. Endukante already aware first nunchi cheptunna nenu J element mass cannot be considered as a common element because of only single direction displacement. And if you observe here B1 another other end is grounded kavati you can't consider this one as a common element, hence K1. And similarly for between theta 2 and theta 3 J2, B2 and K2 ఉన్నాయి కానీ K2 మాత్రం ఎందుకు వస్తుందంటే J2 అనేది mass, B2 is another end is connected to what ground. Just write the differential equations. You will be getting 3 differential equations for this one at theta 1, theta 2 and theta 3. That's it. An exam point of view, nobody will be asking you to find out what the transfer function for 3 nodes. I am saying this statement based upon the knowledge of previous 20 years question papers. Maximally you will be getting only 2 nodes, that is theta 1 and theta 2. Endukante we are not testing your mathematics, just simply we are testing whether you know how to find out the transfer function or not. Adi find out cheyalante finally I am going to conclude that there are 5 steps lo follow aitam. First step is you have to go for what using this writing this extracting the data from the given problem. ఆ తర్వాత at each and every node you have to write the equation. Now ఈ node కి మీరు equation రాస్తే, suppose for example if you want to write the equation for this node, then ఏం రాస్తారమ్మా? If you want to write the equation for this node, just before concluding, just stay here. I didn't take any attendance. So at node theta 1 you will get that t is equal to j1 d square theta 1 by d square theta 1 by dt square plus b1 d theta 1 by dt plus you will get common element is between k into theta 1 minus theta 2. And the same way at the node 2 there is no torque. 0 is equal to j2 d square theta 2 by dt square plus b2 into d theta 2 by dt plus, now if you observe this node 2, one common element is k1 which is with respect to theta 2 minus theta 1, and also another common element is there for theta 2, that is k2 which is with theta 2 minus theta 2. ఇది చాలా మంది మర్చిపోతారు. And now finally the last equation is 0 is equal to j3 into d theta 3 by dt all whole squares plus b3 into d theta 3 by dt plus k3 into theta 3 plus only one common element, that is k2, which is now this time with respect to theta 3 minus theta 2. ఇంతవరకే అడుగుతాడు. ఒకవేళ 3 nodes ఉంటే write the differential equations. Now finally I am giving you guarantee that you will be getting only 2 nodes, so that it will be easy for you, just applying Laplace transformation and writing the exam based upon, you will be asking in the examination based upon your time factor. Time factor is also very important. 3 nodes 4 nodes ఇస్తే ఇంకా మీరు అది చేసుకున్న వచ్చేసరికి గంటన్నర అయిపోతుంది. That's why examiner will prefer to ask only for 2 nodes, but as additional problem I have solved this problem. Any nodes you can unmute or talk. Unmute and talk. Let me take the attendance. Any doubts you can unmute and talk. Be feel free here. Here is the end of my today's class. The final conclusion is, let me give my final conclusion here. So the final conclusion here is so just today we solve this problem. This is the procedure. First, assume the number of nodes as a theta. How many nodes? Theta or theta 1, theta 2, theta 3 based upon the given problem. Next, draw the corresponding free body diagram. Write each and every equation for each node. Then apply Laplace and then find out the ratio of what theta 2 or theta of a, whatever it may be. He is asking either theta 2 of s by t of s or theta 1 of s by t of s based upon the given question. Here is the end of the final concept, that is determination of transfer function for the second type, that is mechanical rotational system. In the tomorrow's class we will be finally concluding this mechanical system and this complete transfer function using mathematical procedure. Here is the end of my class. Now you can log out. You can continue for the next classes.